me just introduce Kerry. He leads the Asset Health Center initiative at AEP. He's got decades of relevant experience, and he's been kind enough to take the time to share his real-world experiences with all of us. And I know that he's got some great lessons to learn. So, Kerry, thanks very much for stopping by.
Thanks for inviting me. And so welcome, everyone. I wanted to share the AEP Asset Health Center program vision and where we're at. So first I want to show you what our AEP transmission, it's one of our business units is transmission. AEP transmission technology, we have 5 different technology focus areas. One is the system awareness, competitive design, operational excellence, public policy, and execution speed. And the Asset Health Center area is under system awareness. So that's what we're going to focus on today, and I'm going to talk through that with you guys. So we're finally, like the movie says, as Yoda says, we're finally becoming masters of our system and our assets. And it's not in a galaxy so far away. We want to know the condition of all our assets, we want to know what to do about it, and we want to know when to do it. And that's what we're going to talk about today. So we have 3 different problems that we are trying to solve with our Asset Health Center solution. One is an aging asset population combined with pressure to reduce operations and maintenance costs. Basically, we have transformers, 33% of those are more than 50 years old, and 34% of our circuit breakers in service are more than 30 years old. So we definitely have an age problem, but we don't want to spend more on maintenance costs. So how do we solve that problem? Our current policies that we do everything on time-based schedule and not look at the condition or the health of equipment at all. And sometimes we just run things to failure, which reduces or increases our chances of unexpected outages and decreases our reliability. The second problem we're trying to solve is just a data issue, a data process aggregation issue. We don't have good maintenance and failure documentation, and some places we just don't have it in the right places. We have it on desktops or laptops and not in an aggregated system. So we're trying to create a system where all this data can be housed in one place and in one process, one way to look at things. And then also, with us not having all the maintenance and failure data in the right place and the right time, then that opens us up to compliance-based fines. So the general overview of the Asset Health Center, there's 2 major parts of this project. One is technology, and that includes monitoring technology, sensing technology, and the Asset Health Center application tool and infrastructure. And then the other part of the project that's a major piece is process. And we're using our technology to help us identify process improvements and gaps in our process, but we're also using the process, the business cases, the use cases, and the problem statements to drive our technology as well. So they both are integrated. So the 3 main purposes of the Asset Health Center are preventing failures, optimizing maintenance, and prioritizing asset renewal. And we're using all the operational data and the new technology that's out there with related to sensing and monitoring and putting that into one central database. And then basically the 3 focuses of the project as far as pieces that we want to work through. One is the development of this infrastructure and the Asset Health Center databases and the tool itself. And then we want to monitor all new equipment, and then we also want to retrofit monitor all existing equipment. So what's the business case? Why are we doing this? Besides some of the problems we think, but what's the real cost savings that we're expecting and real near-term benefits? One is capital savings benefits based upon avoidance of unexpected failures and failure prevention. We're also going to be able to prioritize our spending. We don't have unlimited capital. So since we don't have that, we want to make sure we're spending and replacing the correct assets at the right time. Right now, it's all age-based. So if something's 50 years old and another thing's 50 years old, which one do you choose over if you don't have enough money to do both? We want more input to make those decisions. Also, we need to avoid or redeploy our maintenance costs. Again, this isn't an endless bucket of money either. So we want to make sure we do prioritization of maintenance and are maintaining assets that really need it and not just based on a 6-month schedule. Also, again, like I said before, we're going to have all our data in one place, so that's going to be very valuable. We're going to have increased knowledge of events that happen if a transformer fails or we have some kind of fault. All that information is going to be available to us, and it's going to be, in a way, trending that we've never had before. And then again, we'll also reduce our compliance risk, which has a financial benefit as well as benefits for regulatory. So the long-term vision is we're going to go ahead and install all new transformers, circuit breakers, and batteries with a standard monitor package. So we're also going to, as far as in 2014, we're going to start equipping and doing retrofit on all of our extreme high voltage equipment. So Anything that's higher voltage, we're going to also be doing retrofitting on those, and that's going to be over 10 years because it's going to be a lot of equipment and expensive as well. And then we're going to continue to improve this process over phases, over years, as we get new monitors, new sensors, new data sources. So all those things are going to improve as where we go. And then once we get more technology, more monitors in place, we're going to have an exponential benefit rise. So the principles that we go to when we come into work every day working on Asset Health Center, here's what we ask ourselves. First, we're going to do no harm. We want to make sure that when we put monitors in place, when we're doing processes, that it's not making things worse. For example, sometimes monitors can have more maintenance than the equipment. This equipment's around for years and years and decades, and we don't want to, have a piece of equipment that needs monitored every month when really we don't have to go up to every 6 months because of the equipment schedule. It just defeats the purpose. We also need commitment to solving the problem, which is what we have now in AEP, which has been great for us from the leadership all the way down to the people out in the field that are doing the process. We also want to leverage what we already have in our system. So, for example, relays. Relays have tons of information. We have all this information that's being sent into the substations. But a lot of it we're not using it or not using it in a way that it's aggregated and trendable and way to look at things in a way we haven't before. And another principle of ours is automating inspections and test procedures in real time, building standard sensors into all new devices, refitting existing assets in progressive stages. And then the last two principles, just to go over this in a little more detail, basically we want to have a central tool, this Asset Health Center tool, and make sure that that centrally stores all the data, has all the algorithms and all the information, and we'll talk about that in the next slide or two. And then from a local level, that's where we want simple, resilient, low-cost, low-maintenance sensors that don't have all this algorithm and things that they do locally. We want that sent to a central place, and then the central place has the algorithm and the intelligence in it. So now talking about the Asset Health Center solution, or where we're at right now. So this is an ABB Technology Alliance. This is where this sprung from. It's a 4-phase, 2-year project that we're doing right now, and it has collaborative with AEP and ABB, subject matter expertise, and it also allows our AEP to help define use cases for the industry. And the program right now is transformers, circuit breakers, and batteries across transmission. And that'll grow at some time, but that's just the first phase, 4-phase, 2 years project that has that scope. The solution is going to have a web-based tool that our transmission personnel can get to via AEP intranet. It's going to have trending from several different data sources, and I'll go into that a little bit later. And then we're going to have dashboards or visualizations for asset renewal, maintenance planning, failure reporting, and then the leadership dashboards as well. So this is just an overview of kind of how things are coming into here, real high level. So the Asset Health Center algorithms that we're using, again, they're co-developed by our SMEs and our technical folks as well as ABB. We're basing it on several different pieces. There's industry standards, historical information on the equipment and the assets, failure studies, etc. And also the analysis or algorithms are based on different sampling rates. So if you have an online monitor, or it could be a monitor from offline DGA readings, for example, dissolved gas analysis, the algorithm will treat each of those differently and has different ways to understand that, hey, this is an online monitor, we're getting this data every second. Let's take a look at this in a different way than something we get every 6 months. And we can also use comparative family information and look at an individual asset and compare it to an asset family. So the available data sources, there's 3 main pieces of data that are brought into this tool. One is nameplate data, inspection data, maintenance data, and that ISIS there, that's basically our personal or AEP brand of inspection data system. Test files, global DTA web, which is in our industry, is very useful, and then also trending of historical data. And then also there's real-time SCADA data that's loaded in, and that's examples of that are like loading, temperature, operations information. And then finally, we're deploying all these monitors out, and that's going to have real-time sensor information. That will really change the game for us, because right now most of our readings, our measurements are more at a 6-month, yearly type interval, and we don't see as much monitors in place as we need to make this very valuable going forward, as it will be once we get these in place. So the solution that we're building with ABB, there's a web-based interface that we have with transmission personnel. You can view the asset condition, You can look at real-time alarming for field personnel. That's available. Asset health prioritization, remaining useful life. And then you also have business trends or dashboards that you can use to help understand where your asset conditions or your fleet is at. So that's going overview of the technology. We're in the second phase of the technology right now. And we're just getting the algorithms better, we're getting the visualizations better, we're getting the dashboards better, we're getting input from all the different SMEs on both sides of the equation there. So we're really excited, and it's going really well as far as where we're at with that and where we see the vision going. The next two slides are based on monitoring. So one of the key things about the monitor technology is, one, we want to monitor what matters most. So for transformers, for example, we want dissolved gas, we want the dielectric readings, core and coil information and bushing measurements. For gas circuit breakers is what we're concentrating on right now. The mechanism, the contact, the insulating medium control. I mean, a lot of the stuff Gary talked about as well. And then for batteries, there's certain things in the string we're interested in. And then also individual cell readings and trending that we're looking at as well. And the key point of this slide is we want to monitor, like in the past, historically, monitors haven't always been as specific or as simple and low cost and low maintenance that we need. And we want to focus just on key measurements that really matter, that really help with the health of the equipment, and not have a one-size-fits-all type monitor that really does more than we want. And we want this simple. And then finally, this is a view of things or ways we can improve how our past monitoring experience has been with AEP, inside of AEP anyway. One is a lot of times we focused on things that were easy and not what really mattered, and that kind of goes back to the previous slide. For example, maybe it was easy to look at something on the outside of the transformer rather than have a monitor or a sensor on the inside where things are really happening. But maybe we spent a lot of money or a lot of time on that, but it doesn't have as big a benefit as it would if we really would have focused on what mattered. Installation cost. A lot of the monitors are expensive. In particular, when you look at a battery, monitors are expensive compared to the cost of a battery. So we really need to look at what we measure and how we decrease that cost. And then maintenance effort, like I talked about a little bit before, if the monitor takes a lot of maintenance, there's nothing that the field personnel dislike more than anything is going out to do maintenance on a monitor. That's an absolute no-no. So, and we've had that problem before in the past, and that's something that we need to work with all of our monitor vendors to make sure that we have simple, low-cost, low-maintenance monitoring. And then finally, performance. A lot of times the performance wasn't exactly how we needed it for the monitors. They didn't always do what we wanted, when we wanted it, and how often we wanted it. They didn't do exactly what we needed. And then lastly, for software and firmware, there's sometimes where the data would go in places where it wasn't easy for us to bring it out into this central database where we want to bring it. Or maybe the data was actually at a vendor's place, and we had to actually try to do queries or do other things to get to the data. Where we want to own the data, we want the data to be in our system, an AEP network, so that we can do what we want with it, when we want it to do, and make it happen, basically. So I think that's the only things I wanted to go over today. So thanks for everybody's time.
Thanks very much. We've been listening to Kerry Schneider of AEP. He's been recounting his experiences in building an Asset Health Center at AEP. And thanks especially, Kerry, for your, you call them reflections, I call them lessons learned. That's so helpful to get that information from the horse's mouth.